So guys, in the previous video, we saw the preparation of aldehydes. That is, first important reaction we have seen was called as a Rosamond reduction reaction, where we were converting our acid or acyl chloride to respective aldehydes by treating with palladium catalyst, which was supported over barium sulfate. One important reduction reaction. Soon after the Rosamond reduction reaction, we also came to know another important named reaction, which was called as a Stephen's reaction, in which we were converting the nitriles or cyanohydrocarbons to first imines by treating your cyanohydrocarbons with stannous chloride in a concentrated HCl. Then whatever the imine you have obtained, it was undergone an acid hydrolysis to give you the respective aldehyde. So these were the two important named reactions we have covered in the preparation of the aldehydes in our previous video. So in today's video, we are going to see another important preparation of aldehydes, that is from hydrocarbons. From hydrocarbons. So basically, in this concept, once again we are going to see two important named reaction. One which is called as an Etard reaction, and the other most important thing is called as a Gatermann-koch reaction. Gatermann-koch reaction. So first and the foremost thing, let us deal now one by one. So first let us see what is this Etard reaction. Once again, I would just like to say you, it's a named reaction. In organic chemistry, named reaction has its own significance. So remember, as we have seen in Rosamond reduction, it was the conversion of acid chloride to your aldehyde. In your Stephen reaction, we came to know it was a conversion of your nitrile to aldehyde. Whereas in an Etard reaction, it mainly involves the conversion of our methyl benzene. That is, in this case, I am taking toluene. That is your methyl benzene. Toluene is the common name. Yes. So when toluene is treated with chromyl chloride, please note the formula of chromyl chloride, CrO2Cl2. Getting my point? So I am talking about now Etard reaction, where we are treating our toluene with chromyl chloride. Chromyl chloride, that is CrO2Cl2, in the presence of carbon disulfide, or in certain cases we also use your carbon tetrachloride. So we are not taking the water as a solvent, instead we are taking the solvent as a carbon disulfide or a carbon tetrachloride. So what is here happening over here is, so when your toluene is treated with the chromyl chloride in the presence of your carbon disulfide, basically first you will be getting a chromium complex. What you are going to get? A chromium complex. First let me write how it is given in your textbook. So CH you are going to get, here you will be having your O, and here you will be having your Cr, OH, Cl2 whole twice. So this is actually the chromium complex. If I write it in a proper bond representation, it would be easy for you. Just I am writing this part over here, okay? You can just see over here how it is written. So this is your benzene ring. Yeah. So basically, you just now have a look. Sorry, here it is CH. It is looking like O, right? It is CH. So here you are having now C. Okay. And I will write my H over here. Of course, now it has been bonded with two oxygens in this way. O2 over. Then comes your Cr. Then comes over here your Cr. Yes. Here is your OH. Here is your OH. Then here Cl, 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 Cl. Now you just you can just compare both of these structures. Of course, we are having a CH, we are having a CH. 2O, 2O, 2Cr, 2Cr. OH is twice, OH is twice. Cl is 4 times, 2 2s are 4, so Cl is 4 times. So instead of writing this overall structure, we have written as in this way, CH, in the bracket O, Cr, OH, Cl twice, the whole twice. So this is a very much important, I will say this why it is important. So first, when you are treating your toluene with a chromyl chloride in the presence of your carbon disulfide or a carbon tetrachloride, first we are getting a chromium complex. We are getting what? A chromium complex. Then upon acid hydrolysis, we would be getting our respective benzaldehyde. That means what? First, let me give you it is an extra part what I am saying, okay? So first, where it is breaking, first it will break over here. So you will be getting a H and here H, and here you will be getting as Cr, OH and a OH when you're treating with the water, first part. So first this part is getting converted to the structure. I'll just write the structure. So here you'll be getting as a CH, OH and an OH. Then on removing, when you add acid to it, dehydration process takes place, and then you will be getting your respective benzaldehyde. So instead of, we had just neglected this part in your syllabus or in your NCERT textbook, so they had given you directly. What is that? When toluene is treated with a chromyl chloride in the presence of a carbon disulfide or a carbon tetrachloride, first is getting converted to a chromium complex. So when you're writing the chromium complex, uttermost care has to be taken about what type of an atoms and how many numbers you're writing. Is that clear? Then on acid hydrolysis of this chromium complex, you will be getting your benzaldehyde. Is that clear? So this is called as what? Etard reaction. So first anybody will ask you, right? Etard reaction. Give a brief note on Etard reaction. So what you can see, it's a reaction which involves the toluene treating with the chromyl chloride in the presence of carbon disulfide or carbon tetrachloride gives us the chromium complex, which upon acid hydrolysis gives us the benzaldehyde. Is that clear? So this reaction is called as what? Etard reaction. Coming to the concept wise now, remember whenever we are using this chromial chloride, I'm talking about not general. So whenever we are using this chromium chloride, it mainly attacks your methyl group. Or in simple words, I can say that it first oxidizes the methyl group to respective chromium complexes. Okay, here in case you have taken as a toluene, but if any compound, if you are choosing which is having a methyl group and you are using a chromic chloride, first it is going to attack that methyl group. It is going to convert it into the respective chromium complex. Then on further acidification, acid hydrolysis, you will be getting your respective aldehydes. So that is one of the main use of our chromyl chloride, which is having the formula as CrO2Cl2. Is that clear? So it's a conversion of your toluene to benzaldehyde. Coming to now another important named reaction, which is called as Gatermann-koch reaction. Gatermann-koch reaction. Let me write it over here. Gatermann-koch reaction. Okay. So basically, in this reaction, it mainly involves the conversion of your benzene or its derivatives, it could be. But in your syllabus, just they have given a reaction which is involving benzene. But generally, I'm talking about a Gatermann-koch reaction, remember. So it's in this reaction, basically, we are going to convert benzene or its derivatives to respective benzaldehyde by treating in the presence of carbon monoxide and hydrogen chloride in the presence of anhydrous aluminium chloride. That means what? So remember, when I write the reaction, you'll come to know. So when benzene, yes, it is treated with carbon monoxide in the presence of hydrogen chloride, and remember, very much important, anhydrous AlCl3. In certain cases, we also use cuprous chloride. In certain cases, we can also, instead of using your anhydrous AlCl3, we can also use our cuprous chloride. So when you're carrying out this reaction, of course, we will be getting our respective benzaldehyde. So this reaction is called as what? Gatermann-koch reaction. So what is the main thing we have to understand over here is, whenever we are talking about a named reaction, first and the foremost thing we have to understand what type of a reactants you are using. Okay. Since I am saying this because in Rosamond reduction, it was there also we have obtained what? Benzaldehyde itself. When do we obtain benzaldehyde? When we have treated benzoyl chloride. Alva. So it's a conversion of a benzoyl chloride to benzaldehyde. Coming with respect to your this one Stephen reaction, it was the conversion of nitriles to aldehyde. Getting the difference. Of course, in all the cases, the products are same, but the reactants are different. So that makes a lot of difference when you're studying this organic reactions. Coming with respect to Etard reaction, it was the conversion of just toluene to benzaldehyde. Yes, but when you're coming with respect to the Gatermann-koch reaction, it's a conversion of your benzene to benzaldehyde. And how you're getting it? So when benzene is treated in the presence of carbon monoxide, do remember, carbon monoxide you have to write as capital C and capital O. Some of you write as capital C and small o. It is not carbon monoxide. Instead, it becomes a metal which is called as what? Cobalt. Completely different. It will be wrong. So you should be, uttermost care has to be taken when you're writing this compound structures. Okay. Carbon monoxide, both capital C and capital O. In the presence of hydrogen chloride and in the presence of anhydrous AlCl3. In certain scenario, we can also use our cuprous chloride. So when you're taking this reaction, of course, the final product we are going to obtain is called as benzaldehyde. If it was a substituted, for example, if I'm saying a derivatives, benzene derivatives, then of course you will be getting as what? Substituted benzaldehyde you would have obtained. That's it, nothing more. If you are having a nitrobenzene, of course you would have got as a nitrobenzaldehyde, like that. So that is the major important thing. So these reagents are very much important. These reagents are very much important. Why it is important? Let's have certain examples. Now, for example, I will give you a reaction. You just predict the product. So first, let me take my, okay, this is my chlorobenzene. Let me take my chlorobenzene. In the presence of sodium, and let me take my methyl chloride, CH3. Identify the product A. Okay, identify the product A. Then what I will do, on treating this one, on treating this A with CrO2Cl2 in CS2, identify your B. Identify your B, or directly I can say as then upon acid hydrolysis, identify your B. This is my first part. So what we can see over here, yes, here we are relating the chapters of haloalkenes and haloarenes with that of your, which one? Now what we are dealing, aldehydes, ketones and carboxylic acid. How is that so? What is this reaction? What is the name of this reaction? So this is your Wurtz-Fittig reaction. Alva, it is your Wurtz-Fittig reaction, where you are treating your aryl chloride with an alkyl chloride in the presence of your sodium metal. So what happens? Fusing takes place. So A you'll be getting as what? Very good. First here you're going to get as a toluene. You're going to get as what? Toluene. Yes or no? Then once you have got the toluene, now you're going to treat it with chromyl chloride in CS2. Of course, now only we have seen this will be an Etard reaction. This will be what? Etard reaction. Of course, here we have done acid hydrolysis also. So B, after istumatra bardidre, CrO2 and CS2, you would have got as chromium complex. But also I have added what? Acid hydrolysis I have added. So final B you should get as what? Benzaldehyde. Are you getting how we are relating the chapters? So in organic chemistry, each and every chapters are interrelated. So whenever you are obtaining certain products, you try to jump to your back chapters and try to analyze, is there any relationship between them? Similarly, for Gatermann-koch reaction also I can give you. From phenol we can prepare. How can you prepare phenol from benzaldehyde? Yes, of course. So this is my phenol. I'm going to treat it with zinc dust. Zinc dust. Identify your identify your A. Treat this A with your carbon monoxide, HCl, in the presence of anhydrous AlCl3 or your cuprous chloride. Identify your B. Of course, it's a reaction which is involving which one? Alcohol phenols chapter. Yes, reduction of phenol in the presence of zinc. So what you're going to get over here? Of course, A will be our benzene. A will be our benzene. What about your B? Just now we have seen the Gatermann-koch reaction when benzene is treated with the carbon monoxide in a HCl in the presence of anhydrous AlCl3. We will be getting our benzaldehyde. Can you see how we are relating the reactions? So this is the way of understanding your organic reaction. If you're dealing with one chapter, don't forget the other chapter. Try to revise those chapters by seeing these reactions itself. See, by using now Etard reaction, I have also now revised my Wurtz-Fittig reaction. Yes, by seeing now your Gatermann-koch reaction, I have also now revised my reaction of phenol in the presence of zinc dust. So when you do like this, there is no need that you had to memorize. Instead, it gets, what you can say, understanding capability increases. So this is the way of relating your organic reactions. Is that clear? Very much important according to your syllabus. So far we have completed the preparation of aldehydes. First was your Rosamond reduction, where we were treating our acid or an acyl chloride in the presence of palladium catalyst supported over barium sulfate. We were getting what? Benzaldehyde or respective aldehyde. Similarly, we saw with respect to the Stephen reaction, I am highlighting only the reaction names because they are all named reaction. So there we have converted the nitriles, yes, respective nitriles, treated in the presence of stannous chloride in a concentrated HCl to give you the respective imine, IMINE, which upon acid hydrolysis gave us the respective aldehyde. And of course, I have given you an additional information over there about DiBOL-H, diisobutyl aluminium hydride. Recall it. Then we came to know of today's video. We came to know about the from hydrocarbons how we are preparing, and there we have analyzed about two important named reaction. One is called as an Etard reaction, where we are converting the toluene in the presence of chromyl chloride, Cr, that is your chromium, O2 Cl2. So overall it is called as what? Chromyl chloride. First it is getting converted to your chromium complex, very much important, C6H5CH. Within the bracket you will be having what? O2, yes, or you can say as a what? CH, O, Cr, OH, Cl2, the whole twice. Yes, very much important, which upon acid hydrolysis gives us the benzaldehyde. Then we came to know another important named reaction, which is called as what? Gatermann-koch reaction, where we are converting the benzene or its derivatives to benzaldehyde by treating with carbon monoxide in the presence of HCl and in the presence of anhydrous aluminium chloride or cuprous chloride. So where we are getting our respective benzaldehyde. So these are important named reactions we have came so far according to your syllabus. Okay, very much important. So till now guys, till now whatever we have read is with respect to the second PUC point of view board exam. But when you are coming with respect to your competitive exams, there is another two important, or I can say another four important reactions as per your NCERT books. So we will go with that under the concept of my video, which is called as what? Additional information. Additional information. So remember, in my videos, whatever the additional information is there is the information which is derived from your NCERT books, but they are not included in your second PUC board exam syllabus. Is that clear? Very much important point. So first let me deal with one such additional information, that is from hydrocarbons itself. How can we prepare our respective aldehyde? So basically we have seen the Etard reaction where we have used a chromyl chloride. Now we are going to see that by taking the same toluene, With the help of chromic oxide, how can you prepare your benzaldehyde? A simple reaction. What happens? You just remember the reactions and about your respective importance of your reagents. So when toluene is treated with a chromic oxide, remember, in the presence of acetic anhydride, how will you write it? CH3CO whole twice O, acetic anhydride, at nearly we can say as 273 Kelvin temperature, 273 to 283, or different temperature range you are maintaining. First, you are going to get benzaldehyde diacetate. How can I write it? So this is your benzene, CHOCOCH3 twice. So this is the major difference between your chromyl chloride and chromic oxide. So this is called as what? Benzaldehyde diacetate. So there, when you are using your chromyl chloride, there we have got as what? A complex of chromium. But when we are using here as a chromic oxide in the presence of your acetic anhydride, here we are not getting a chromium complex. Instead, we are getting a compound which is called as what? Benzaldehyde diacetate, which upon acid hydrolysis, you will be getting our benzaldehyde. We will be getting our benzaldehyde. Okay, very much important reaction according as per your competitive exam point of view. Remember, in your competitive exams, first you have to be thorough with your NCERT textbook equations or reactions, because major reactions will be coming from that textbook itself. So I would like to cover the part which is not included in your second PUC board syllabus, because all the students are not having the same potential. Some of the students will be having that potential, so I would not like to leave those parts. Okay, because these are the reactions which is going to emerge in your competitive exam. So there is a need, you have to understand these reactions also. So what happened when toluene was treated with a chromyl chloride? Of course, we got a chromium complex. But when the same toluene was treated with the chromic oxide, CrO3, in the presence of our acetic anhydride in the range of temperature of 273 to 283 Kelvin, first you will be getting a benzaldehyde diacetate, which upon acid hydrolysis will be getting what? Benzaldehyde. Similarly, there is another method of conversion of your toluene to benzaldehyde. Basically, it is called as a side chain chlorination, which is followed by a hydrolysis. That is what we have to just treat with a chlorine. You have to just treat with a chlorine, which is called as a chlorination of toluene. So first, what happens in the presence of sunlight, we are doing it. So first you are going to get, please note the word of the structure, or what is the structure's name over here. So this is called as CHCl2. First you are getting as what? CHCl2. Remember, it is called as what? Benzyl chloride. Benzyl chloride. Are you able to notify the changes? Benzyl chloride will be how? C6H5CH2Cl. This is called as what? Benzyl chloride. Alva? Benzyl chloride. Yesterday we came to know from the Rosamond reduction reaction, what was that? Yes, when your benzene ring is having C6H5COCl. So this was called as what? Benzoyl chloride. This was called as what? Benzoyl chloride. Today we are coming to know about a new name which is called as what? Benzyl chloride. Very much important to note these names, so don't get confused. Okay, what has happened? Instead of CH2, here we will be having as what? Only CH. Instead of Cl, we will be having here Cl2. Able to identify the difference? So this is called as what? Benzyl chloride. So this is our benzyl chloride, this is our benzoyl chloride, this is our benzyl chloride. So when your toluene is undergone a chlorination in the presence of H mu, first you are going to get a benzyl chloride, an important product, because there may be a chance they can give you all these three options and identify which part you are going to get. So remember, it is benzyl chloride. Then which upon acid hydrolysis, H3O plus, we will be getting our benzaldehyde. We would be getting our benzaldehyde. Are you able to understand the importance of these reactions? Of course, it's similar to that of your Etard reaction itself. Instead of using the chromyl chloride, In the first case, we have used what? Chromium oxide in the presence of acetic anhydride. Of course, the reactant and the final product is same. But the only difference is the reagents. Are you able to notify the changes? When I use the chromyl chloride, I have got a chromium complex. That is the importance of the reagents. So when I am using my chromic oxide in the presence of acetic anhydride, I am not getting a chromium complex. Instead, I am getting my benzalidene diacetate. But final product is same. But the way of getting the final product is different. Similarly, when toluene is treated with a chlorine in the presence of sunlight, first we are getting data benzyl chloride, which upon acid hydrolysis will be getting our benzaldehyde. Remember, this is our commercial process of manufacturing of our benzaldehyde. In industries, basically we adopt this method because it is one of the less investment and easily we can get a good yield of our benzaldehyde. So commercially or manufacturing, commercial purposely benzaldehyde, even the method in the manufacture. Is that clear? Okay. Now coming to my point on interesting reactions we are going to study. That is, how can you prepare aldehydes from alkenes? How can you prepare aldehydes from? So they are called as by ozonolysis, or more particularly I can say as by reductive ozonolysis process. By reductive ozonolysis. So before going to the reactions, first let us understand what is the importance of these reactions, or what is the importance of the ozonolysis. Remember, this ozonolysis process is very much important in, we can say, structure elucidation. Structure elucidation. That means what, sir? Basically, through this ozonolysis process, we are able to understand, or we are able to judge the position of double bonds. We are able to judge the position of double bonds. You will come to know why I am saying this when we see certain important reactions. This is the first important process. And remember, whenever your alkenes are reacting with the ozone, first they will be giving you cyclic ozonoid structure. Cyclic ozonoid structure. Then which upon hydrolysis in the presence of zinc. This zinc plays also a vital role, which you come to know when I will be explaining the reactions. Finally, you will be getting your carbonyl compounds. Carbonyl compounds means basically here it includes your aldehydes and ketones. Okay, your aldehydes will be obtaining, both the aldehydes and ketones will be obtained depending upon what type of alkenes you have chosen. So first let us deal with it. So how does the reaction takes place? Let us see first. In the first case, I am using my simplest alkene, that is my ethene. So when ethene is treated with ozone, as I have mentioned, it is going to give what? Cyclic ozonoid. See the structure, how I am writing, very much important. So CH2O, CH2, and here you will be having one more O, one more O. So this is called as what? Cyclic ozonoid. In this case, it is called as ethylene ozonide. Ethylene ozonide. Here you can only notice what is that? Ozone is attacking those carbons which has been doubly bonded. So that is the major role of this ozonolysis, where we can predict where is the position of your double bond. So which upon treatment with zinc, hydrolysis, soon after doing the hydrolysis, here what you will be getting, see the product CH2O plus CH2O, nothing much. This part will be obtaining the final product. This is the way of remembering this reactions. Final break agi, the CH2O means what it is? It is HCHO plus HCHO. That means formaldehyde. Overall, we can write formaldehyde in this way also. How come? CH2O. So CH2O anta notidira andkule, you have to judge yourself that it is an formaldehyde. So this was the case when I have obtained ethene, I have obtained formaldehyde. Let us take some unsymmetrical ethenes. For example, let me take CH3CH double bond CH2 plus O3. So now first ಎಲ್ಲಿಗೆ attack ಆಗುತ್ತೆ ozono? Yeah, very good. Only to these carbons. So now it will be coming CH3, CH, see the structure O, CH2, here comes O, here comes O, yeah. So that forms what? Propylene ozonide, which upon treatment with zinc in the presence of water, so what will happen? This part would be coming, this part would be coming. That's it, nothing much more. Alva? Only you have to add O and O, it will be giving you the final products. Very much important to remember this trick when you are doing in your competitive exams. Just you have to add O wherever you are having that doubly bonded carbon. So ಇಲ್ಲಿ ಒಂದು O na add ಮಾಡಬೇಕು ಅಲ್ವಾ ಫೈನಲ್ ಪ್ರಾಡಕ್ಟ್ ನಮಗೆ ಅದೇ ಬರ್ತಾ ಇರೋದು. No need of writing all those things. I'm only writing to ensure that you are better understanding how the reaction is proceeding ಅಂತ. ನಿಮ್ಮ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಅಲ್ಲಿ ಕೊಟ್ಟಾಗ ಡೈರೆಕ್ಟ್ಲಿ ಜಸ್ಟ್ ಡ್ರಾ ಒನ್ ಬಾಂಡ್ ಆರ್ ಒನ್ ಲೈನ್ ಅಂಡ್ ಆಡ್ ಇಯರ್ ಒನ್ ಆಡ್ ಇಯರ್ ಒನ್. ಅವಾಗ ಇದೇನಾಯ್ತು CH3 CHO, ಇದೇನಾಯ್ತು CH2O, which means formaldehyde and acetaldehyde ಅಲ್ವಾ. You can just see. So ಏನಾಗುತ್ತೆ CH3CHO plus CH2O. Is that clear? Now let us do with one more thing. Okay, you predict it directly. CH3CH2CH double bond CH2 plus O3. So ಏನ್ ಬರುತ್ತೆ ಫೈನಲ್ ಪ್ರಾಡಕ್ಟ್ ಬರೀಬಹುದು ನಾವೇ. ಇಲ್ಲೇ ಒಂದು ಬಾಂಡ್ ಹಾಕ್ಬಿಡೋಣ ಆಯ್ತಾ. ಇಲ್ಲಿಗ ಒಂದು O ಬರುತ್ತೆ, ಇಲ್ಲಿ ಒಂದು O ಬರುತ್ತೆ. ಅವಾಗ ಇದೇನಾಯ್ತು? Very good. It is called as what? Propanol you are getting. Propanol plus formaldehyde. If I write it, its ozonoid structure, how can I write it? So CH3 is there, CH2 is there, ozone is attacking only your doubly bonded carbon. So CH, here comes O, here comes CH2, here comes O, here comes O. So this is our ozonoid structure, which upon treating this one in the presence of zinc in water, we will be getting our respective propanol and formaldehyde. You take an example of butene now. Butene. So CH3, CH, double bond CH, and here you will be having your CH3 plus O3. So what you can predict directly ಬರೀಬೋದಾ? ಇಲ್ಲಿ ಒಂದು ಲೈನ್ ಬರ್ಕೊಡಿ. Here one O, here one O. So here you will be getting as what? CH3CHO, CH3CHO. That is, in both the cases you are getting 2 moles of acetaldehyde or ethanol. So if I want to write its ozonoid structure, CH, mark here O, CH, O, O in this way, CH3, which on treating in the presence of zinc in water, so what will be happening over here? You will be getting as CH3, CHO plus CH3, CHO. Getting my point? So till now, whatever the products we have obtained was the aldehydes. Now you just see over here. If I am going to choose my 2-methyl propene, let me write it in this way, CH3 double bond CH2 plus O3. Remember, see what here you can get just as the same protocol you do. O and a O. So here we are getting not an aldehyde, instead we are getting a ketone over here. So that is the reason I said you can get aldehyde or ketone, it depends upon what type of a alkene you are choosing. So you can just write it over here, CH3, CH3, yes. Here we will be having O, here you will be having your CH2, O and an O. So treating this one with zinc in the presence of water. So what is the final product we are going to get? Very good. CH3 double bond O. So we are getting a propanone plus CH2O, that is formaldehyde. So this is the very much important reaction, guys, because in most of the cases in competitive exams they have asked it. Reactions, they will be giving you certain alkenes and they will treat with the ozone. So what is your task? You just, wherever the double bond is there, you just split that bond and write O over there, and you can only predict the structure. No need of doing all this reaction. I'm only doing this reaction to ensure that you know how the reaction is progressing and how you are going to get your final products of carbonyl compounds. Is that clear? Very much important. And here I would like to add a note. I said you the important reaction of this ozonolysis was why we are using this zinc over here ಅಲ್ವಾ, ಯಾಕಂದ್ರೆ ನಾವು ಇಲ್ಲಿ ನೋಡ್ತಾ ಇದೀವಿ ಇಥೈಲಿನ್ ಓಝೋನಾಯ್ಡ್ ಆದ್ಮೇಲೆ ನಾನು zinc ನ ಯೂಸ್ ಮಾಡ್ತಿದ್ದೀನಿ. The main reason is why, because I'll just say, so as soon as your alkenes are treated with ozone, of course we are getting what? Cyclic ozonoid. Along with the cyclic ozonoid, we are also getting hydrogen peroxide. What we are getting? Hydrogen peroxide. So this hydrogen peroxide, we know it's a good oxidizing agent. So it doesn't keep quiet. So once it has been generated in the system, what it will try to do, it will try to show its strength. That is, it will try to oxidize your aldehydes to carboxylic acids. I repeat, the hydrogen peroxide which will be obtained during this reaction will try to oxidize your aldehydes to carboxylic acid. So in order to prevent that reaction, because I want to stop the reaction in aldehydes itself, I don't want carboxylic acids. So in order to prevent that reaction, what I will do, I will use my zinc. So when zinc is there, of course, whatever the hydrogen peroxide will be obtained soon after your cyclic ozonoid, so that will be reacting with zinc because it's highly reactive. So it will be giving you zinc oxide plus water, reducing the strength of your hydrogen peroxide. It will not have the capacity to further oxidize your aldehydes to carboxylic acid. So that is the main reason why we are using zinc over here. Very much important. Certain scenarios they can ask you this part of the question also. Why zinc is used in ozonolysis process? The main reason is whatever the hydrogen peroxide which has been obtained in the reaction system, it will react with the zinc to form zinc oxide and H2O, where our hydrogen peroxide loses its oxidizing nature to oxidize your aldehydes to carboxylic acid. So our reaction will be stopped at the aldehydes itself. That is the reason overall this process is called as what? Reductive ozonolysis. Reductive ozonolysis. Why I am saying this? Because you are also having an oxidative ozonolysis, which I would not like to deal now. In the certain other cases, I will just show you how to deal with it because I don't want to confuse you. But you remember, whenever you're treating your alkenes in the presence of ozone and in the presence of zinc, it is called as what? Reductive ozonolysis. I repeat, reductive ozonolysis. Come to know what is the importance of zinc also in reductive ozonolysis. Is that clear? Very much important reaction called as reductive ozonolysis of your alkenes. So whenever we are doing a reductive ozonolysis of alkene, the final product we are going to get is the carbonyl compounds. It can be your aldehydes, it can be also your ketones, which ultimately depends upon your structures of your alkenes. Is that clear? Okay. Now next important part, of course we have seen how we are converting alkenes to aldehyde. Now it is our protocol to understand how can we convert alkynes to aldehyde. Alkynes to aldehyde, and another important reaction. Yes. So this is by the process called as hydration of alkynes. Hydration of alkynes. So before going through the reaction, I would just like to mention some important points over here. Okay. So basically, in order to carry out this reaction, first we are treating our alkynes with dilute H2SO4 in the presence of mercuric sulfate. In the presence of mercuric sulfate, HgSO4. Nearly at a temperature range, I could have mentioned 338 Kelvin. 338 Kelvin. So when you are carrying out this process, of course, you are going to get your aldehydes and ketones. And one important point which I would like to mention is whenever we are using ethyne, only in this structure itself we are going to get what? Aldehyde. We are going to get an aldehyde. Any other alkynes if you are choosing, in this process, it will be giving you what? Ketones. It will be giving you the ketones. A very important noteworthy point. So whenever you are doing a hydration of ethyne, then only you are going to get an aldehyde. In case if you are using any other alkynes, you will be getting your ketones. Okay. Now let us see with it. One more important thing. Okay, let me say this thing when I'm dealing with the reaction itself. It will be better to understand over there. So let me first take my ethyne structure. Yes, CH, triple bond CH. So when I'm treating this one with H2O, hydration process alva. In the presence of, please mark my words, this is dilute H2SO4 in the presence of mercuric sulfate at nearly 338 Kelvin. So here, see how the reaction is proceeding. CH2 double bond CHOH. First you will be getting like this. Enol compound where you are being having an ene and an ol. Remember, whenever you are getting this enol structure, I have mentioned in my first year itself, it automatically tautomerizes. Tautomerization process. Tautomerizes to give you carbonyl compounds. In this case, it is giving you aldehyde CH3CHO. CH3CHO. ಏನು tautomerization ಅಂದ್ರೆ first ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. So tautomerization is a process, or we can say it's a reaction which involves the transfer of a proton, in an intramolecular fashion. Intramolecular within the molecule ಏನಾಗ್ತಾ ಉಂಟು ಪ್ರೋಟಾನ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಾ ಉಂಟು ಅಲ್ವಾ. ಇಲ್ಲಿದ್ದ ಪ್ರೋಟಾನ್ ಈಗ ಎಲ್ಲಿಗೆ ಬರ್ತಾ ಉಂಟು, ದಿಸ್ ಹೆಚ್ ಅಲ್ಲಿ ಪ್ರೋಟಾನ್ ಡೈರೆಕ್ಟ್ ಆಗಿ ಬಂದ್ಕೊಂಡು ಈ ಕಡೆ ಬರ್ತಾ ಉಂಟು. ಇಟ್ ಇಸ್ ಗಿವಿಂಗ್ ಯು ಆಸ್ ವಾಟ್ CH3. ಸೊ ದೇರ್ ಇಸ್ ಅ ಪ್ರೋಟಾನ್ ಟ್ರಾನ್ಸ್ಫರ್. ಸಿಂಪಲ್ ಪ್ರೋಟಾನ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಾ ಉಂಟು in an intramolecular fashion. So such a reaction is called as what? Tautomerization. So ಏನಂತ ಬರಿಲ್ಲ ಇಲ್ಲಿ. So tautomerization process ಅಂದ್ರೆ tautomerism. So basically the reaction which involves transfer of a simple proton, yes, in an intramolecular fashion. Mark my words, in an intramolecular, which means within the molecule itself, intramolecular fashion. So remember, one of the finest and most viewed tautomerism is keto-enol tautomerism. ಹಂಗಾದ್ರೆ ಅರ್ಥ ಏನು ಸರ್? ಇನಾಲ್ ಇದ್ದು ಕೀಟೋನ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗೋದು. ಈ ಕೇಸಸ್ ಆಲ್ಡಿಹೈಡ್ ಆಗಿದೆ, ಯಾಕಂದ್ರೆ ನಾವು ಇಲ್ಲಿ ಈಥೈನ್ ತಗೊಂಡಿದೀವಿ. ಯಾವುದೇ ಬೇರೆ ಒಂದು ಆಲ್ಕೈನ್ ನೋಡಿದಾಗ ನಮ್ಗೆ ಗೊತ್ತಾಗುತ್ತೆ ನಮ್ಗೆ ಅದು ಕೀಟೋನೇ ಬರುತ್ತೆ. ಸೊ ಜನರಲ್ ಆಗಿ ನಾವು ಈ ಟಾಟೋಮೆರಿಸಮ್ ನ ನೋಡ್ತೀವಿ. ಯಾವತ್ತೇ ಆಗ್ಲಿ ನಿಮ್ಗೆ ಡಬಲ್ ಬಾಂಡ್ ಮತ್ತೆ ಹೈಡ್ರಾಕ್ಸಿ ಗ್ರೂಪ್ ಇದ್ರೆ, ಸೊ ದಿಸ್ ವಿಲ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್ ಇನಾಲ್. ಅದು ನೋಡಿ ಸೈಡ್ ಬೈ ಸೈಡ್ ಅದೇ ಕಾರ್ಬನಿಗೆ ಇರಬೇಕು, ಅವಾಗ ನಮ್ಗೆ ಈಸಿಯಾಗಿ ಬರಕ್ ಸಾಧ್ಯತೆ ಇರುತ್ತೆ. ಸೊ ವೆನ್ ಎವರ್ ಯು ಆರ್ ಸೀಯಿಂಗ್ ಸಚ್ ಡಬಲ್ ಬಾಂಡ್ ಅಂಡ್ ಅನ್ ಆಲ್ಕೋಹಾಲ್, ಇಟ್ ಶುಡ್ ಸ್ಟ್ರೈಕ್ ಯುವರ್ ಮೈಂಡ್ ದಟ್ okay, this compound is undergoing a tautomerization to give you the respective ketones or aldehydes. So that is called as what? Keto-enol tautomerization. And it is mainly observed in this reaction where your hydration of alkynes. As I have said, only your ethyne gives you aldehyde. Why I have said so? You'll come to know when I take one more important reaction of propyne. CH3C triple bond CH. Alva. So this is our propyne. So what we have come to know, so when I am going to hydrate it, H2O, yes, in the presence of dilute H2SO4 and mercuric sulfate, nearly the temperature range is 3838 Kelvin. See the product, how you're getting CH3COH, yes, double bond CH2, double bond CH2. Able to see the difference? So here now we are having ene and an or. So now it tautomerizes. ಯಾವ ತರ tautomerize ಆಗಬಹುದು? ಇಲ್ಲಿಗೆ ಬರಬಹುದು, ಈ ಬಾಂಡ್ ಮುರಿತದೆ, ಆ ಬಾಂಡ್ ಈ ಕಡೆಗೆ ಶಿಫ್ಟ್ ಆಗುತ್ತೆ ಅಲ್ವಾ. ಸೊ ಯಾಕೆ ಹಂಗೆ? ಈ ಕಡೆ ಹೆಚ್ಚು ಬಂದಾಗ ಓ ಮೇಲೆ ಏನಾಗುತ್ತೆ, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ. ಸೊ ಚಾನ್ಸ್ ಇದ್ದಾಗ ಏನ್ ಮಾಡುತ್ತೆ, ಈ ಬಾಂಡ್ ನ ತನ್ನ ಕಡೆಗೆ ಎಳ್ಕೊಂಡು ಅವಾಗ ಏನಾಯ್ತು, ಡಬಲ್ ಬಾಂಡ್ ಆಗುತ್ತೆ. ಸೊ ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ ಆಸ್ ವಾಟ್? CH3C double bond O CH3. Able to notify the difference. So when we took only ethyne, we got as an aldehyde. But any other alkynes we are going to choose, of course, we are not going to get aldehyde. Instead, we are going to get what? Ketone. So that is the reason we are calling this tautomerizing process as what? Keto-enol tautomerism. Keto Alva, keto, enol, tautomerism. Okay. Now one important thing I have to ask you. What is that? If you are not having the question, I will only ask you the question. What is that? Sir, of course you wrote OH to this carbon. That means to this carbon. Why not you can write the OH on this carbon? ಅಲ್ವಾ ನಾನು OH ನ ನೀವು ನೋಡಬಹುದು. OH ನ ಯಾರು ಬಲ್ಬಿಡ್ತಿದ್ದೀನಿ ನಾನು ಈ ಕಾರ್ಬನ್ ಮೇಲೆ ಅಟ್ಯಾಚ್ ಮಾಡಿದ್ದೀನಿ. ಯಾಕೆ ನಾನು ಈ ಕಾರ್ಬನ್ ಮೇಲೆ ಅಟ್ಯಾಚ್ ಮಾಡಲಿಲ್ಲ? ಅಫ್ಕೋರ್ಸ್ ಫಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಅದರ ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ, ಯಾಕಂದ್ರೆ ಇಟ್ ವಾಸ್ ಅ ಸಿಮೆಟ್ರಿಕಲ್ ಆಲ್ಕಿನ್, ಎಲ್ಲಿ ಹೋದ್ರು ನಮ್ಗೆ ಅದೇ ಪ್ರಾಡಕ್ಟೇ ಬರ್ತಾ ಇತ್ತು, ಪ್ರಾಬ್ಲಮ್ ಇರಲಿಲ್ಲ. ಅದೇ ಇಲ್ಲಿ ಮಾತ್ರ ಬರಲಿಲ್ಲ. ನೋಡಿದ್ರ ಅದನ್ನ ಯಾಕೆ? ಹ್ಯಾವ್ ಎನಿಬಡಿ ಹ್ಯಾವ್ ಗಾಟ್ ಅ ಕ್ವಶನ್? ರಿಮೆಂಬರ್ whenever we are adding the water to our alkynes, it follows Markovnikov rule. That it's KOVS, Markovnikov's rule. That itself was my third point over here. Addition of water to alkynes undergoes Markovnikov's rule. What is the Markovnikov's rule states? Yes. The negative part of an unsymmetric molecule, I repeat, the negative part of an unsymmetric molecule. Illi unsymmetric molecule andre yavadu? H2O alva. It is giving us a H plus and an OH minus. So the negative part of an unsymmetrical molecule attacks the carbon atom containing the least number of hydrogen atoms. Yes or no? So ಈಗ ಈ ಒಂದು ಮಾಲಿಕ್ಯೂಲ್ ನ ಕನ್ಸಿಡರ್, ಆಲ್ಕೈನ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಈ ಒಂದು ಕಂಪೌಂಡ್ ಅಲ್ಲಿ ಯಾವುದು ನಿಮ್ದು ಲೀಸ್ಟ್ ಹೈಡ್ರೋಜನ್ ಇರೋ ಆಟಮು? ದಿಸ್ ಕಾರ್ಬನ್ ಅಲ್ವಾ? ಆ ರೀಸನ್ ಇಂದಾನೆ ದ ನೆಗೆಟಿವ್ ಪಾರ್ಟ್ ಆಫ್ ಅವರ್ unsymmetrical molecule attacks the carbon atom containing least number of hydrogen atom. That is the reason I have written the hydroxy group on this carbon. Are you getting my point? Very important point it is. Okay. The other way is not possible. It will, even though it is possible, the yield will be very, very less because it will not be a stable compound. Okay. So these are the important points you have to remember. Okay. So in today's video, we have come across various additional information. Yes. First and the foremost thing, we came to know that we can even convert our toluene to benzaldehyde by using your chromic oxide in the presence of acetic anhydride. We also came to know a commercial way of preparation of benzaldehyde by the chlorination of toluene. Then the other two important things also we came to know that how can you prepare aldehydes from alkenes through ozonolysis, which is particularly called as a reductive ozonolysis. Yes. Then the final thing we came to know about the how can you convert your alkynes. See, both we have studied. We have studied for alkenes, we have studied for alkenes, and when we are studying for alkynes, we came to know that when you are hydrating the alkynes in the presence of dilute H2SO4 and a mercuric sulfate, you will be getting your respective aldehydes. That also are respective aldehydes and ketones. Whenever in that also particularly we are mentioning that whenever it is an ethyne, you are going to get an aldehyde. Any other alkynes, you will be getting our ketones. And there also we are understanding a new process called as a tautomerism, and that tautomerism is called as what? Keto-enol tautomerism. Very much important. Why I am saying it again and again? Because some of your fellows just stops over here. Optionally, ಈ ಒಂದು ಹೆಸರು ಇರಲ್ಲ. ಇನ್ಸ್ಟೆಡ್ ದೇ ವಿಲ್ ಬಿ ಗಿವಿಂಗ್ ಇನ್ ಆಪ್ಷನ್ ದೀಸ್ ಎಕ್ಸಾಂಪಲ್ಸ್. ಈ ಆಲ್ಡಿಹೈಡ್ಸ್ ಕೀಟೋನ್ಸ್ ನ ಹೆಸರು ಕೊಟ್ಟಿಟ್ಟು ನಿಮ್ಗೆ ಗೊತ್ತೇ ಇಲ್ಲ ಅಂದಾಗ ಯು ವಿಲ್ ಜಸ್ಟ್ ಲೀವ್ ಇಟ್. ಇಟ್ ವಿಲ್ ಬಿ ಅ ಸಿಂಪ್ಲೆಸ್ಟ್ ಟಾಸ್ಕ್ ಟು ರಿಮೆಂಬರ್ ಇಟ್. Whenever you are having an ene and an ol, it is going to tautomerize to give you the ketone or aldehyde. Okay. When you are taking ethyne only, you will be getting the aldehyde. Any other alkynes, surely you will be getting your ketones. So that tautomerism process is called as what? Keto-enol. So whenever it is an unsymmetrical alkyne and you are hydrating it, you remember it will be following what? Markovnikov's rule. That is the negative part. That is your hydroxide ion is going to attack the carbon which will be containing the least number of hydrogen atoms. Is that clear? Very much important. Practice this reaction and make a separate note at the end of the chapter. Okay? Very much important. So in the next video, we are going to see how can one prepare ketones because till now we have seen only the preparation of aldehydes. Next we are going to see the preparation of ketones. Okay.